Assalamualaikum warahmatullahi wabarakatuh. My name is AIMAN bin SHAFIE. My metric number is DE190143. So we are from group 42 and we're going to present for the open loop and closed loop speed control system. So I will present activity number 1, which is consists of open loop control speed control system. When in this activity 1, there will be two block diagram. Where the first block diagram is the where we want to vary or where we want to observe the output waveform of input voltage, motor torque, motor speed, and tachometer voltage. After we set the input voltage to 240, and the stop time of the simulation was 10 seconds. So this is the block diagram, and this part is the DC motor where we have two constant here, which is tachometer constant and torque constant. Okay, after we run this simulation, and we will obtain the output of the input voltage is here. Okay, what we can see here, the output of input voltage it start from 0 until rise, and then when t equal to 10 seconds, the output voltage will be 240. And next, the value of motor torque here. The value of motor torque here, it will gradually decreases from the peak value here, which is 46.77. It will decrease when t equal to 10 seconds. The value of the motor torque will be 11.12. And then we need to observe the motor speed. The motor speed here. The motor speed of the this block diagram, it will gradually increase until it reaches a constant speed here at t equal to 10 seconds, where the maximum speed it will reach 3687. And then for the last part, where the tachometer voltage, it can be observed that it also gradually increase until it reach the maximum point here, which is t equal to 10 seconds. The value of tachometer voltage is 239.6 volts. That's all for the block diagram number 1, where we set the input voltage to 240 and nothing changes in the block diagram, and we observe the input voltage, motor torque, and motor speed, and also the tachometer voltage output waveform. So the next block diagram here, we have the same block diagram, but what we upgrade is we changed the input voltage to input speed, and we added a new tachometer constant. In this block diagram, we want to observe what is the input voltage value and the tachometer voltage value if we vary the input speed, where the minimum speed of the motor, which is 400, and the maximum speed of the motor, which is 2600. So the first part, we set the input speed to 240, we set the input speed to 400, and then we run the simulation, and then we will obtain the input voltage value of the block diagram, where we set input speed to 400. The input voltage of the block diagram, when t equal to 10 seconds, it will be 26. It will be 26 volt. And then the tachometer output here will be, or tachometer voltage will be 225.96 when t equal to 10 seconds. Alright. And then I will set the value to the maximum value, 2600. Then we run the simulation. We wait a bit, and then we will see the value of the input voltage. So the input voltage here, when t equal to 10 seconds, it will reach 100. It will reach 169. So here at here, 169 volt. So the tachometer output is, or tachometer voltage will be, when t equal to 10 seconds here, which is time equal to 10, it will be 168.7. It can be observed that when the input speed is higher, when the higher of the input speed, when the value of input speed higher, the higher of the value of input voltage and tachometer voltage. I think that's all for my part, and I will pass to my next friend. Thank you. Assalamualaikum warahmatullahi wabarakatuh. I will present for the activity 2, which is the open loop speed control system. So for this activity 2, we need to repeat the step 4 in activity 1. We need to set the input speed to 2500 RPM. So we use the second block diagram here, which is at the tachometer constant and after the input speed, and then we set the input speed value to 2500 RPM, and then we need to find the input voltage. So we run the circuit, and then we obtain the input voltage at t equal to 10 seconds, which is 162.5 volt. And then after that, after we obtain the input voltage value, we need to use back the first block diagram for the open loop speed control system, where we use the input voltage that we obtained from the second block diagram, where we set the RPM to 2500, and this is the value 162.5. And then we need to obtain the motor speed here by varying or manipulate the brake scale from 0 until 21. So I will only use 3 value for this simulation. So for the first value, I use 0 value, 0 brake scale value. And then after we run the circuit, and then we obtain the motor speed graph here. And when t equal to 10 seconds, here is the maximum speed, which is 2496. Okay, so that when t equal to 10 seconds, and then we adjust the value of the brake scale to 9, and then we run the simulation back, and then we obtain the motor speed here, which is 1803 RPM when t equal to 10 seconds. And lastly, we set the brake scale to 21. We set the brake scale to 21, and then we run the simulation back. And then we obtain the motor speed here, which is 879 RPM when t equal to 10 seconds. It can be concluded that when we constant the value of the input voltage and we vary or we manipulate the brake scale, the motor speed of the DC motor will gradually decrease from 0 until 21. I think that's all for activity number 2. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Azim bin Muhammad FAUZI and my matric card number is DE190145. So I will continue with the activity 3, which is the closed loop speed control system. So in this activity, we are required to construct this block diagram of the closed loop speed control system in the Simulink MATLAB. So this is the block diagram, and as you can see here, this is the DC motor, which consists of the electrical part, the mechanical part, brake, and also the torque constant. For the closed loop system, it consists of the voltage input, the proportional gain, saturation, the tachometer constant, and also the speed output to determine the output of this DC motor. So for the voltage input, we fix the voltage based on the activity 2, which is equal to 162.5 volt, and for the proportional gain we set it to 200, and the saturation for the upper limit we set it to 240, and the lower limit is equal to 0. For the torque constant is equal to 0.05, for the tachometer constant is equal to 0.065, and both this is the equation for the electrical part and mechanical part. So for this activity, we are required to determine the speed output for this DC motor when we vary the brake scale from 0 to 21. So we have to measure the speed output at time t is equal to 10 seconds. So for the initial value, we set the brake scale equal to 0, and then we have to determine the speed output by run the simulation. And then so I have to run the first simulation. And then this is the speed output. We can see here at the scope, by using this cursor measurement here, we can set the time to 10 seconds, and we will see the output is equal to 2488 rpm. So this is for the initial value at the brake scale of 0. And then what we have to do, we have to vary the brake scale here. And then I will not do from 0 to 21. I just take the middle value, which is 9, and then we apply it. We run back the simulation, and then here is the scope, which is speed output. You can see at 10 seconds, the speed of the DC motor will drop to 2484 rpm, revolution per minute. And then for the last one, I will go with the brake scale to 21. Just apply it, okay, and we run the simulation. For the last one, this is the speed output, and then at the time of 10 seconds, we can see that the output rpm is equal to 2073, which is lower than at the brake scale of 9. And then we take the value and we have to plot a graph, and based on the graph we can conclude that the motor speed, or rpm, revolution per minute, was decreased as the brake scale increased, which means that the speed low when the brake scale increase. So that's all from me. Thank you.